So 8.5, write in graph, and I promise these graphs are not as scary as the other graphs we've had. Exponential growth functions. I should say, as long as y'all are paying attention. So tomorrow's will be, the only word will change is growth. It will become decay, but today we're on growth. So, an exponential function has the form y equals a times b raised to the x, where a is not equal to 0 and b is greater than 0 and not equal to 1. These are non-linear functions. So for the purpose of today, x is going to have to be positive, but as far as in general, x can be positive or negative. Or, well, actually, let me rephrase. Sorry. X does not have to be positive. You'll see why in a minute. Specifically for, click the right button, for exponential growth, we have occurs for y equals a times b to the x when a is greater than 0 and b is greater than 1. So that's what I was trying to say, not x. So a has to be positive and b has to be greater than 1. Can be a decimal, but it has to be greater than 1. Within this stuff, and a lot of times this section and next section are taught together, but typically when we're doing stuff with exponential growth and decay, and especially with growth, we'll be looking at things that deal with money as far as like some little word problems, so we may do a couple of them. So the form that it goes with, the exponential growth model, is, and I'm going to write stuff around it, so I would skip a line so that you can write around it. Y equals a times 1 plus r raised to the t. And this is the most baseline form of this model. There are other forms that you'll get, like in Algebra 2 and pre-cal and stuff like that, that are much more involved, but this is all you need to know for now. So a is the initial amount. So like, let's say you got like $100 for your birthday. And you're going to put that all in the bank. That's your initial amount that you're putting in. Now, R by itself is the growth factor. Growth rate. This whole thing, this 1 plus R part, is the growth factor. And T is the time period that it happens over. And Y is like the final amount that you're going to end up with. So these often come up with like interest problems. So like if you put $100 in the bank and you know what your interest rate is, then you can say, okay, well, how much is this going to be worth in 5 years? And that's what this particular formula will do for you. But we'll come back to those at the end, but I just wanted us to go ahead and see that formula. All right, so in this stuff with graphing its function, and then they say to identify the domain and range, we'll talk about that also for these functions. Actually, before we go into this, I want to show you what an exponential growth graph would look like. Because you haven't seen one of these before, so you probably should see what one looks like before we get started. So basically, exponential growth function, it's going to look something like this. It never crosses the axis, the x-axis. It'll just get very, very close to it, and it just goes up. So essentially, as more time passes, it gets bigger is what that does. And so we'll be graphing like around 3 points usually to determine what's happening, and then we'll just connect them. But an exponential growth graph will always look like this. A decay graph, which we'll do tomorrow, will basically be reversed. It'll start high on the left and it'll end low on the right. But this is the only one you need for today. The domain of an exponential graph is all real numbers. The range is going to be from 0 to infinity. Now, if the graph has been shifted up or down, which these first ones that we're going to do will not have had anything happening to them, then that's not the case. But actually, I don't think any of y'all's are going to shift. So,
wait, what does the R stand for?
Range. So it's basically domain is the x values, the range is the y values. And notice it's a parentheses around 0 because it can never actually cross 0. It can just get really, really close to it. Yes.
What is D6? What is that?
It's the fancy R for all real numbers.
Oh.
Or if you want to think about it like this, if you like that method better. Most people like the fancy R though. Okay, now actually into the problems. So we've got y equals 7 raised to the x. So the way I do these, and the easiest way to do these, is with a little table. And so basically we'll be taking and we'll be more or less making a little table and plotting the points. And I usually will go from like -1 to 1, or like -1 maybe up to 2, depending on what it is. And not to say that you have to, but that's typically the easiest. So I'm going to make a little XY table here. So I'm going to say if x is -1, if it's 0, and if it's 1. I just need enough points for me to know what it looks like. Actually, I'm going to do this. I'm going to add another row. It's fine y, but we're going to do the actual solving the problem here in the middle little blank, just to make it easier. All right, so in here, this would be 7 raised to the -1, which would be what? 1 over 7. And then if I had 7 to the 0, what is that? 1. And then I've got 7 to the 1. So that one's just 7. So that one's pretty nice, easy numbers overall. So I'm going to set up a little graph here. With exponential growth functions, I really don't need anything below the y-axis. You should extend it down just a little bit, but you don't really need anything crazy. -1, 0, and 1. And then I'm going to go, I know I need to go up to 7. So 1, 2, 3, 4, 5, 6, 7. So at -1, I have a point at 1, 7. So I'm just going to be barely above the axis here. At 0, I'm at 1. So this point is here. And then at 1, I have a point up at 7. So that one's all the way up here. And then I just make my little exponential graph. It's a little crazy here. But notice it's curvy. And it just goes up like that. So this should be nice and easy. Now, the reason I choose typically -1, 0, and 1 is because if I went and I kept going, come back. If I kept going, let's say, and did 2, and then I had 7 squared, what is that?
49.
49. Do you really want to put 49 on the graph?
No. Not really.
Not really, right? You'd have to change your scaling altogether and all of that. You just need 3 points. You need one on the left side, one on the y-axis, and then one on the right side, and that's more than enough to graph your function. So not too bad. Now, not to say you can't do 49 and rescale it, but that's going to be a lot more work than just doing like -1, 0, and 1. Let's see. 12. Y equals 9 to the x. So I'm going to do the same thing I did with the last one here with this one. I'm going to do -1, 0, and 1. So in this middle one, I'm just going to do my work. So 9 raised to the -1 is what?
1/9.
1/9. Here, 9 raised to the 0 is
1.
and over here, 9 raised to the 1 is
9.
9. So, set up my graph. And then I'm going to plot these points. So at -1, I'm at 1/9. So again, I'm just putting it somewhere, basically just right above the axis there. At 0, it's at 1. And at 1, it's at 9. And then just connect the dots. Make it as rounded as possible. Obviously, it's not perfect, but that's okay. So notice this kind of starts off small, like just choosing the values, and then all of a sudden it gets really big really fast, right? Because if I kept going, 9 squared is what?
81.
And that point would be like way up here, right? And it just keeps getting higher and higher up the farther that you go. So that's what exponentially we're getting larger.
Actually, wait, never mind.
Okay. Jumping to 18. Y equals, in parentheses, 7/2 raised to the x. So what's different about this one?
Fraction.
It's a fraction, but what is that fraction equivalent to?
Proper.
What's it equivalent to?
3.5.
Okay, about 3.5, right? So that's still a number that's bigger than
1.
Yep. So, still a growth function, and that'll be more in play tomorrow when we have ones that aren't bigger than 1. But I'm going to do the same thing, set up a table. I'm still going to use -1, 0, and 1. So 7/2 raised to the -1 is what?
7 to the -1/2 to the -1.
Okay, which is what?
2/7.
2/7. The negative just tells me to flip that. It's just raised to the first power, so I'm just flipping the fraction over. 7 over 2 raised to the 0 is
1.
I seem to have that down. That's good. 7 over 2 raised to the 1 is
7 over 2.
Yep, so 7 over 2, if you want to think about it, since you're going to be graphing and instead write it as 3.5, that's totally fine also. If you want to leave it as 7 over 2, also fine. Up to you. So I'm going to set up to graph. Notice this one, it's not going to be as big, right? So negative 1, 1, 1, 2, 3. Now, since it's at 3.5, I'm going to go up to 4 so that it's easier to see. So at negative 1, I'm at 2 over 7, still a number smaller than 1, so I'm just going to put it down here. At 0, we're at 1. And at 1, we're up at 3.5, 7 over 2. And then we're just connecting here. So notice, on these ones, where it's just a number being raised to x, every single time at 0, it's equal to 1, right? When x is 0, y is 1. You see that? Every single one that we've had has been that case. Now, the next ones, if there's a number being multiplied in front of it, that's not necessarily true. Okay? So, if I have something like 22, y equals 2 times 3 raised to the x. So I'm going to set this up the same way with my table, but it's just going to look a little bit different in the actual math of it as I'm solving it. So I'm still going to use negative 1, 0, and 1. There may be an occasion where that ends up giving us a really big number depending on what's going on, and that's okay. So when I plug in negative 1, this is 2 times 3 to the negative 1. Well, what's 3 to the negative 1?
1 over 3.
1 over 3 times 2 is
2 over 3.
2 over 3. And if you need to put more space in here to write that other stuff out, if you need to see it better or whatever, you can do that too. Leave an extra space. You can rewrite this. It'd be 2 times 3 to the negative 1. So this is 2 times 1 over 3. However you need to do it for you. If you need to work it out to the side, you don't like the table for putting the little, the math part in, that's fine too. But you do need to have, show what the x equals and y equals. Because if your points are off on your graph, I can at least see, okay, did you do the math right? And then are we just plotting points wrong or, what's going on? And then I've got 2 times 3 to the 0. What would that be equal to?
2.
2, because this would be 2 times 1, which is 2. And then at 1, I have 2 times 3 to the 1, which is 6. So notice now at 0, it's not 1 anymore because it was being multiplied by this 2. So it's actually at 2. So on this graph here, the graph itself is still shaped the same way. It just it just goes up higher. So at negative 1, I'm at 2/3. So I'm going to try to put this up a little bit farther than the other ones have been because obviously 2/3 is 0.6. So I'm going up about halfway, a little over halfway. At 0, it's up at 2. And at 1, it's at 6. And then I'm just connecting like that. Do 2 more of these. How are we feeling about these so far?
Yeah.
Easy,
Good,
but I
easy.
Still don't like graphing.
It's time consuming, but
Exactly.
Yeah. Well, the good news is tomorrow the only real difference is that the graphs will be going the opposite direction. So tomorrow's not really going to be anything crazy different. All right, so 24, y equals 1/4 times 3 to the x. I just realized in every single one of these, oh, I guess it's because that's what the instructions say. In 22 through 23, it's always 3 raised to the x just times a number. I was like, why did they choose all 3s? Well, apparently, because I didn't read all the instructions. It says graph the function and compare to the graph of y equals 3 to the x. We're not doing that part. We don't really ever do the compare part. Anyways, I just thought it was interesting. All right, so the table. Also, I realized I didn't do anything with domain and range, but the domain and range for the purpose of the problems that we're doing, not going to change from the original one that I told you, so we don't even need to worry about it. All right, still -1, 0, and 1, and you're always welcome to use other numbers. I just think these are the easiest. All right, so I've got 1/4 times 3 to the -1. So what does this 3 to the -1 do? 1/3. So I'm just going to say, okay, I ran out of room, so I'm going to do it down here. So 1/4 times 1/3 is what?
1/12.
Yep, 1/12. Then I've got 1/4 times 3 to the 0 is?
It's 1/4.
Yep, because it'd be 1/4 times 1, so this is just 1/4. And then at 1, I've got 1/4 times 3 to the 1, which is?
It's
3/4, yep. Now, what do you notice about this problem compared to the other ones that we've done?
It's a lot smaller.
All these numbers are fractions, right? And they're all less than 1, okay? So that's fine, but I'm going to show you what I would do a little bit different when I graph compared to the other ones. Now, this is a problem that perhaps I should have chosen bigger numbers, done like maybe 0, 1, and 2, and gotten some bigger numbers. But it doesn't matter. I can always use these. So I'm just going to show you how I would graph it slightly different just because of this. So what I would do, since all my numbers are less than 1, I would actually count and call this like 0.5 and this 1 so that I'm making it a little bit more of like a dramatic difference, because otherwise all your points are just going to be, because like graphing 1/12, 1/4, and 3/4, they're all going to be pretty like tightly packed and it's going to look more like a straight line. So this way it'll be a little bit more obvious what's happening. So this 1/12 is going to barely be above the axis here. At 0, 1/4, well, that's essentially 0.25, so that's halfway between here. And then at 1, it's at 3/4, which is halfway between half and 1. So now I've just changed my scaling a little bit so that it just looks a little bit more dramatic. Not to say you have to do it that way. Different ways I could have done it. Doesn't matter, and I would get the same thing. So. All right, last one of these, and then we might look at 1 or 2 of these little word problems here just so that we're familiar with it. All right, let's see. 28. Y equals -2 times 3 to the x. What's different than this problem?
There's a negative.
There's a negative this time, so we'll find out what happens when there's a negative in front. So, I don't know why I just wrote y first. X always comes first. So I'm still going to go with -1, 0, and 1. Leaving myself a little more room for the math than I did on the last one. All right, so I've got -2 times 3 to the -1. What would that give me?
It give you -2/3.
Yep, because this would be -2 times 1/3. So -2/3. With 0, I would have negative 2 times 3 to the 0.
Negative 2.
Yep, so negative 2 times 1 is just negative 2. And then negative 2 times 3 to the 1 is?
Negative 6.
Negative 6. What's different about the answers to this one?
They're all negative.
They're all negative. So where does that mean my graph is?
On the bottom side.
It's on the bottom. So instead of putting all the stuff on the top this time, it's going to be on the bottom. So I need to go down instead. So I always draw my graph last because I want to make sure I know where my points are going. All right, so at negative 1, I'm down at negative 2/3. So notice it's below the graph this time. At 0, it's at negative 2, so it's down here. You can just sit right there. And at 1, it's at negative 6, so that's down here. So notice this graph is going down. So it's basically just the normal growth graph flipped over the x-axis. It just took it from up top and it just flipped it down to the bottom, essentially, is all that happened with that being negative. The negative tells you that the graph got reflected. It's the only thing about it.
Are we even growing anymore? Because it seems like we're going down with this one.
You technically...
You're just growing back. Yeah, I know. You're just like...
Technically, yes. It's just growing in the opposite direction. Because the negative 2. Still growth, it's just negative, so it's reflected over the axis. All right. On the word problems here, there's only one of these in your book and it's even, so I'm going to leave that one for you. I'm going to do a different one. So you put $250 in a savings account. That earns 4% interest. Compounded yearly. So again, right now this is all that we have the formula for. Later on in math, you'll have it if it happens, like if it's compounded more often, which most banks are at least 4 times a year, but sometimes are more. Anyways, you do not make any deposits or withdraws, so we don't add or take away any money from our account. We just leave it to sit there. How much will your investment be in 5 years? I guess I should say be worth. Now, on these problems, you probably are going to need your calculator, just because we're going to be dealing with some decimals raised to a power.
My calculator is bad. Right. That's a good thing to say.
Now, on the test, if I were to give you one of these, and since we don't usually use calculator on our test, either I will let you use it for that one problem, or you will just be required to set it up, okay, and just take it as far as you can without actually doing that, because not that you can't do some of these things by hand, but it would make it a lot more difficult. So our formula was y equals a times 1 plus r raised to the t. So the initial amount that we're depositing is A, which is $250. So I'm going to put all this stuff out to the side. So $250. R is 4%. But when I plug it in, I've got to turn that into a decimal. So what is 4% as a decimal?
0.75.
0.04. So it has to be a decimal. I did not specify that up here. I'm going to go back and write that in. Growth rate as a decimal. I know it's a different color, but I don't care. Okay, so that's got to make sure that you put that in as a decimal or you're not going to get the right answer. So the other thing then that I need is t, because y is what I'm solving for. It's 5 years, so t equals 5. And I'm trying to solve for y. So y equals 250, and I don't need to put the dollar sign on it right now, times 1 plus r is 0.04 raised to the 5. So this is 250 times 1.04 raised to the 5. So this is where, not that you can't multiply this out, but that would be a pain to multiply this out if you did not have a calculator. We would stop here, okay? But if we do have a calculator, we keep going. So we're going to do 250 times. Now, most of you only have a basic calculator, so you're just going to have to multiply 1.04 times itself 5 times. So it'll be, now depending on, actually, let me just use my basic calculator. All right, so basically what I'm going to have to do, because I don't have an exponent button on here, I would just have to do 1.04 times 1.04. So that's, so far I've done it, so I've used 2 of them. I've got to do it basically 3 more. So times 1.04 times 1.04. And I got to do it one more time. So that ends up being, I know it's hard to read up here, but 1.216652. So I would say just round, well, it's technically money, so we usually do 2 decimal places. But at this point, before I'm done, okay, so hold right there for just a second. This will be 1.21, I'm just going to say 7. Now, with your calculator, I can hit that multiplication button again, and I can multiply it by the 250. And so that would be $304.16, because money always has 2 decimal places, right? So y would be, with the dollar sign, $304.16. So if you didn't touch your money at all at a 4% interest rate, after 5 years, you would have $304.16. So you basically made about $54.
In 5 years, I'm getting scammed. For real.
But if you keep it at home, you don't make any extra.
So, like, since what do I do since, like...
Sam must be tired.
My calculator's dead. I'm not...
Then you ask somebody to borrow theirs.
Alright.
You wait until you're after school with your phone and you do it. Or you put a note here that I don't have a calculator. And you stop there. Is yours not working?
No, it is.
Hers is completely fine. She just doesn't want to do the work. Mine is just dead. Mine has been dead for I don't know how long.
So, anyways, does that make sense?
Yeah.
And then depending on obviously what rate they give you, obviously that would change the answer as well.
Here, they give me 1 plus 1.
All right, so problems for this section are, not going to give you like a crazy amount because you just don't need to do that many. 9, 19, 23, 25, and 29. And then on the word problems, number 38, I just want you to do B and D. Okay, if you want to do the others, that's fine, but that's all you need to do. 38 is a word problem just like this one. Okay, it's a different interest rate and a different starting amount of money. And then B is 2 years, D is 20 years. So instead of it being 5 here, the first one's going to be 2, the second one's going to be 20.
I only earn like $5 in 20 years.
That's the only thing. Well, it's a small amount of money. The bigger your amount of money, the more money you're going to earn. Which is why you should start saving money now.